Okay, we're going to be doing lead code 633, sum of square numbers. This is a medium question, but it's quite tricky because you need to remember your math and all that. So you're given a non-negative integer called c, and suppose decide whether there are two integers a and b such that a squared plus b squared is equal to c, right? So these integers could be, c is between 0 to, this is like, I don't know, like some billions of numbers or something like that. So this is a very large input, right? So our search space for the possible values, which you can add up, because there'll be these two values which add up to c, right? Once you square them in any case, they're definitely less than c, right? If it was just a plus b is equal to c, then they would definitely be less than c, right? So let's do it like this. So we're looking for numbers a squared plus b squared is equal to c. That automatically means that these three numbers are different, right? A is different, b is different, c is different, right? These two may be of different lengths, of different sizes, right? But what we do know is that c is larger than a and b for sure, right? So our search space will be from 0 to whatever is less than c, right? Some value less than c, right? But what we're going to do is we're going to have two pointers, one at this end and one at this end. And we're going to check if I squared plus j squared is equal to c, then we found it, and thus we return true. Otherwise, if this I squared plus j squared is less than c, then it means we need to push our I forward. Otherwise, if I squared plus j squared is greater than c, then it means we need to push our j to the left, right? So now, about our search space, right? If our c was 25, then that means that the square root of 25 is the larger of the values of a or b, right? A plus b squared is equal to c, right? If you have any number larger than the square root of 25, which is 5, as a or b, then this won't work out. For example, 6 squared plus, say, 0 squared will give us 36, which is larger than 25, right? So that means our search space should go from 0 to the square root of c. But we need to convert this into an int because some of these numbers, like 5, square root of 5 will give us a float, right? So let's do it, right? So we're going to set our I to 0. So let's write our search space for possible values of a and b is 0 to less than c. Furthermore, optimization is from 0 to square root of c, right? So our I is there, j is equal to, we're going to first do the longer version. We're going to say is equal to c minus 1, right? Because it can never be c, right? C can never be one of the values a or b, right? So then while I is less than or equal to j, this is not binary search, it's two pointers, right? This is two pointers and not binary search. So while I is less than or equal to j, and the reason it works is because this is it's a sorted search space is equal to sum of squares is equal to I to the power 2 plus j to the power 2, right? We're checking whether this at this 0 and this is sum of squares. So if sum of squares is equal to c, then we found it. We found a and b as I and j. So we return true. If sum of squares is less than c, then we need to push our lower pointer forward. I is equal to is plus equals 1. Since it's not like cutting off large chunks, then it's not binary search. We're just moving by one position. Else, our sum of squares is greater than c. Right? And obviously here we don't care about the equals because we've already dealt with it here. Then we need to push our higher pointer j backwards to get closer to c. So j minus equals 1. And then when we get out of here, we simply return false because we failed to find it in our search space. Right? So let's do that. Hold on a second, from 0 to 1. From 0 to 1. You can put here an edge case of if c is less than or equal to 1, then you simply return true. Because yes, 0 squared plus 1 squared is equal to 1. And 0 squared plus 0 squared is equal to 0. So for any number greater than or equal to greater than 1, that's where our conditions work, the conditions that we looked at earlier. So let's see, right? But then it takes too long. Right? You see, it takes too long. So what we're going to have to do is we're going to upper bound it by the square root of c. And we have to make sure it's an integer, so square root of c. So when we run this, it works, voila. And we don't need this because our search space is from 0 to square root of c. Right? The one thing I don't understand is why when we set this, the reason why it didn't work is if you set this, then we should have just set it to c. Right? It would have worked for the case 1. Because when you do c minus 1, you don't consider the fact that 1 may equal to 0. So anyway, square root of c. So this is you have to understand the search space for a and b, and then you have to remember, in order to optimize it, you have to remember to do this, right? So that it doesn't take long. Otherwise, there's another solution which is brute force. Let's just look at the brute force solution. So for I in range C, for J in range C, if I squared plus J squared is equal to C, then you return true, else you return false. This also works. You have to deal with the edge cases. So if C is less than or equal to 1, you return true. This should work as well, but it exceeds our time limit, so we have to we have to, right? You see, it exceeds the time limit. So this is the solution. And it's 2 pointers, not binary search. So that was the solution, and thank you. Bye.